Thanks for coming. Good morning. Thanks for coming, everyone. So my name is Kota Tsuzaki. I'm working for NTT, Japanese telecom company, and working for also upstream work, OpenStack upstream projects. I'm working for Swift as a core developer, and for Storlets, I'm working, running a role of the project technical lead. So I'm really glad to introduce our experimental result to apply OpenStack Swift and Storlets for our use case. And that is for the large-scale image processing. So let's get started in my presentation. So at first, I would like to explain the components we use in my presentation. So we are using the two-component OpenStack Swift and Storlets. Swift is the object storage instance developing in the OpenStack, and that exists in the OpenStack first release. And that is really good production scale because that can be deployed to the common hardware and its scale. So, and the other is OpenStack Storlets. That is for creating computing environment inside of the object storage. So you can deploy your application inside to Swift, and you can modify, change your data in the locally. So let me describe more detail in the later slide for OpenStack Swift. Swift is, object storage. Object is the file method. File is, the anything of the data. Is like the PDF, movie, picture, music, anything you are handling in the popular life. And the metadata is the more extra information related to the file. For example, this picture is taken at the Boston OpenStack Summit, and that happened in the May this year. So something like that. So when who is in here, where that photo is taken at the extra information at metadata. And the object storage is for the storing the object in scale. Especially OpenStack Swift is the great stuff because that is really highly scalable and durable. That's because, so you can, if you want to the more volume or performance, you can attach your common hardware to scale, and OpenStack Swift stores your objects for several times, so that avoid the data loss from your disk drive failure. So, but I think I know Swift is absolutely a powerful tool to build massive data storage, but the question is, would store retrieve your data enough for your application? I think sometimes yes, sometimes no. That is the concept for storage. Storage is the application inside storage, and your application can be run at the upload and downloading time. For example, in this picture, objects can be uploaded into Swift just for raw data. However, sometimes someone wants to reduce the more information, like the privacy information or coloring, to reduce the network for security or network efficiency. So you can build a storage application and deploy in the storage environment, and you can retrieve just a grayscale and without face photo. But Swift can keep the raw data inside still. So this is storage architecture design. But I think I have not so much time to describe all of the architecture. So the point I would like to describe here is your application is running on inside the Docker sandbox. So Storlets launches the Docker container inside in Swift. So your application cannot access any Swift environment anymore. So that means the absolutely safe, and it can be it can make some restriction for according to your application to when the application running. That's a great point, I think. So this is our proof of concept work to apply our production software. So this is large-scale image processing. So this is called Advanced World 3D Project. Advanced World 3D Project is our grouping company, Entity Data, is doing. So the Advanced 3D is a project providing high-resolution 3D map for customer. Mainly, the 3D data consists of either digital elevation model or digital surface model. And so to create high-resolution where all world 3D map, they need to process tons of satellite picture images that will reach approximately 4 petabytes total. So we need a huge amount of storage, and we need more effective processing. So on the procedure on the 3D mapping, there are several processes of computation. Stereo matching is one of the process we are focusing on this proof of concept work. The stereo matching is the major technique to calculate the depth and height with 2 picture inputs. So we feed 2 satellite image, almost raw image scanned by satellite, and to create the image, a 3D model. So we need to run a lot of satellite image processing application container so much. So each raw satellite image is almost several gigabytes, and for covering the all over the world, we need to store a bunch of images on the processing environment. So we estimate Swift is a good price to store such a large number of big images, and using storage effect to save network transfer to process the image pair doing inside the storage system. This is our proof of concepts. And to be honest, I would like to explain whole the benchmark result, but this is lightning talk. I have not enough time to describe everything. However, the lessons I learned in this proof of concept work, the first 1-2 item is really good. The one is I'm really sure that can be scaled, and especially data volume and parallel processing for even this 3D mapping model proof of our use case. And the second is really easy to deploy the application to progress our proof of concept work immediately. However, item 3.4 is not so good enough for currently for us. That's because the 3D mapping processing is really expensive CPU and RAM expensive work rather than I expected. So we need to buy more expensive CPU RAM for storage, but it may be not required for OpenStack Swift. And the item 4 is a problem for the temporal workspace. So legacy applications sometimes want to dump their state to the local file system, and that will be in the storage container. So that we need to prepare the disk file space to run our application. But like item 4, it's really good input for upstream development. So we can modify, we can fix the to support the program in upstream. That's what I learned in this proof of concept. So Storlets is now, you may know, Storlets is an official project of OpenStack. So you can join our Storlets team to develop or use something. Please join our Storlets team. Thank you.